Welcome to this lesson on Newton's first law of motion, also known as the law of inertia. In this video, we'll explore one of the most fundamental principles in physics that explains how objects behave when forces act on them, or when no forces are present at all. This law helps us understand why objects resist changes in their motion. Newton's first law states that an object at rest remains at rest, and an object in motion remains in motion at constant velocity, unless acted upon by a net external force. The key words here are constant velocity and net external force. Constant velocity means the object moves at the same speed and in the same direction. A net external force is any force from outside the object that causes it to change its motion. This law is also called the law of inertia because it describes how objects resist changes to their state of motion. Inertia is the resistance of an object to any change in its state of motion or rest. Simply put, inertia is the tendency of objects to keep doing what they're already doing. If an object is sitting still, it wants to stay still. If it's moving, it wants to keep moving. An important fact to remember is that greater mass equals greater inertia. This means heavier objects have more resistance to changes in motion than lighter objects. For example, it's much harder to push a car than to push a bicycle because the car has more mass and therefore more inertia. Let's look at some examples of inertia with objects at rest. A book on a table remains stationary until someone pushes it. A ball on the ground stays in place until it's kicked or thrown. When you place a coin on a card and quickly flick the card away, the coin falls straight down instead of moving with the card. This happens because the coin's inertia keeps it at rest while the card moves. Similarly, when you shake a carpet vigorously, dust particles separate from it because they tend to stay at rest while the carpet moves. All these examples show that objects at rest will remain at rest unless a force acts on them. Now let's examine objects in motion. When you're a passenger in a car and the driver suddenly applies the brakes, you lurch forward. This happens because your body wants to continue moving at the same speed even though the car has stopped. An ice skater continues gliding after stopping the pushing motion because their inertia keeps them moving until friction slows them down. Satellites in orbit keep moving in a circular path without using fuel, thanks to their inertia and the balance of gravitational force. A running athlete cannot stop instantly at the finish line because their body's inertia keeps them moving forward. These examples demonstrate that objects in motion tend to stay in motion unless a force acts to change their speed or direction. A net external force is required to change an object's state of motion. Without a force, an object will continue doing what it's already doing. Forces can affect motion in three main ways. First, a force can start motion by making a stationary object begin to move. Second, a force can stop motion by bringing a moving object to rest. Third, a force can change direction by altering the path of a moving object. Remember, the key word is net external force. This means the total force acting on the object from outside sources. If multiple forces balance each other out, the net force is zero, and the object's motion doesn't change. There are some important insights to understand about Newton's first law. First, force is not needed to keep an object moving at constant velocity. This is a common misconception. Once an object is moving, it will continue moving at the same speed and direction without any force as long as nothing interferes. Force is needed only to change the motion, which means to accelerate or decelerate the object. In real life, we observe that moving objects eventually slow down and stop. This happens because friction and air resistance act as forces that oppose the motion. Without these resistive forces, like in the vacuum of space, objects would continue moving forever at constant velocity. Understanding these concepts helps us see how Newton's first law applies to the real world. To summarize, Newton's first law tells us that objects maintain their state of rest or uniform motion unless a net external force acts upon them. This fundamental principle is the essence of inertia. Remember that inertia is not a force, but rather a property of matter that describes its resistance to changes in motion. The more massive an object is, the more inertia it has, and the more force is required to change its motion. This law forms the foundation for understanding all of mechanics and helps explain countless phenomena we observe in everyday life and in the universe around us. Thank you for watching this lesson on Newton's first law of motion.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.